Hello, let's start the chapter Triangles, chapter 6 of your Ncert book. Today we'll learn about similarity. But before that, let us recall that in class 9 we have learned about congruent triangles. So what do you mean by congruent? When two polygons or when two shapes are exactly equal in both shape and size, then those polygons are known as congruent polygons. Two figures or polygons having the same shape are called similar polygon. So, the difference between congruent polygon and similar polygon is that in case of congruent polygon, both the polygons must be of same shape as well as same size. But in case of similar polygon, if two figures or polygons are of same shape, then those are known as similar polygons. That means congruent polygons have one more condition of size to be equal. Okay? Let us go through some examples. Here are two figures. These two figures are neither of the same shape nor of same size. So both of them are neither similar nor congruent. These two figures are both triangles. One is a scalene triangle and another looks like a right angle triangle. Even though both of them are the same polygon, still neither they have the same shape or size. That's why they are neither similar nor congruent. Now, these two shapes have both same shape as well as same size. So we can say both these shapes are congruent. They are congruent to each other. And as because their shape is also same, we can say that the two polygons here or the two circles here are also similar. In these two figures, we can see that both the shapes are equal, but one is of smaller size and another is of greater size. So clearly from here we can say both of these circles are not congruent, but they are definitely similar in nature because they have the same shape. So here we can see on the left hand side we can see two circles which are of the same shape and same size. So they are both congruent and similar. But on the right hand side there are two circles which have same shape but they do not have the same size. So from here we can conclude that all congruent polygons are definitely similar, but all similar polygons are not congruent. Okay? As because they have the same shape does not mean they always have the same size. So all the similar polygons will not have similar sizes. So they will not be congruent. So in this last example, we can see both the figures are polygons of three sides, that is triangles. Both of them are same polygons. Both of them have same shapes. That means they are similar, but they are of different sizes. So they are not congruent. So here we can say that these last two triangles are similar in nature. So they are similar triangles. When we say two triangles are similar, that means that if the corresponding angles in two triangles are congruent, that means the corresponding angles should be equal. This is a very known fact from congruency chapter. But what else do we have? And the sides are proportional. In case of congruency, the sides also should be equal. Angles are equal as well as sides are equal. but in case of similarity, the angles will definitely be equal for corresponding angles, but the sides will be in proportion to each other, or they will have the same ratio. Okay, so here we can see angle A is equal to angle D. They have the same angle. Angle B is equal to angle E. They have the same angle. And angle C is equals to angle F in the two triangles. But what about the ratio? Let us say that each of these particular sides of the triangles have different lengths. If we take out the ratio of the length of AB and the length of DE, okay, AB by DE, okay, these are the corresponding sides. If AB is equals to AB by DE is some particular value, say X, and we can find that AC by DF is also some particular X. If the value of the ratio of AB by DE and AC by DF is equal, and also BC by EF is also equal to X, then we can say that this ratio is true. Okay, so what did we say? AB by DE, then AC by DF, then BC by EF. If we take out the ratios separately, if this is an similar triangle, if these two are similar to each other, then this ratio will be equal to each other. Okay, and if they are not similar, you will get different fractions. Okay, so from here what we can say, that if two triangles are similar, then all their corresponding angles will be equal and all the ratios of the corresponding sides will also be equal. Okay, then we can say that it will be similar. Basic Proportionality Theorem. If a line parallel to one side of a triangle intersects the other two, then it cuts off segments which are proportional to these sides. So let us take a triangle ABC. In the triangle ABC, let us draw a line segment. Okay, let us make sure that this line segment is parallel to the base of the triangle ABC, that is parallel to BC. Now, when the line passes through the sides of the two triangles, we can see that this line is intersecting AB at D and AC at E. According to the Basic Proportionality Theorem, or Thales theorem, who proposed it, AD by DB will be equal to AE by EC. That is, when this line is drawn parallel to the base here, then the line is actually dividing the whole triangle into two sections. Okay, that means the length here AD by DB will be equal to, on the right hand side, AE by EC. So if we take out the length, we will see that we will get this ratio. Okay, this is the Basic Proportionality Theorem. This is a theorem which says the exact thing as the Basic Proportionality Theorem. That is, if a line parallel to one side of a triangle intersects the other two sides in distinct points, then the other two sides are divided in the same ratio. Okay, therefore we'll have AD by DB is equals to AE by EC. It can be further said as AB by DB is equals to AC by AE. We can take the full sides and also write down the ratio. Next, we have the converse of basic proportionality theorem. It is exactly opposite to what we have learned in the basic proportionality theorem. In the basic proportionality theorem, we had a triangle and we have drawn a line which was parallel to one of the bases or the base. But here we have the opposite thing. Here, if a line intersects two sides of a triangle and cuts off segment proportion to sides, then it is parallel to the third side. Now it is saying that suppose we have a triangle, okay, and the triangle is divided by a straight line. In the ratio AD by DB is equals to AE by EC. We have the ratio, okay. Then it says, the theorem says, then DE will be parallel to BC. Okay, so by basic proportionality theorem we have learned that if DE is parallel to BC for a triangle ABC, then we will get the ratio AD by DB is equals to AE by EC. But in the converse of basic proportionality theorem, we have just the opposite, that if a line is drawn through a triangle, then if the ratio formed of the sides is AD by DB is equals to AE by EC, then we can say that the line is parallel to the base, just the opposite of it, or vice versa. Using that, we will solve exercise 6.2. Now we will go through few of the theorems to prove similarity of triangles. The first one is AAA similarity. Okay, before we start it, let me say that the main criteria that we have learned for being similar was that all the corresponding angles should have been equal and all the corresponding sides should have been in proportion, or the ratios would have been same. These are the two criteria based on which we can say two polygons are, or triangles are similar or not. But we have few theorems which states that if we go by those theorems, that both the conditions are not required to be proved. If we prove one part of it, we can actually say that they are similar. Okay, so here we have the AAA similarity criterion, which is also a theorem, and it states that if the corresponding angles in two triangles are congruent, that is equal, then the triangles are similar. If we can prove that all the corresponding angles are equal, then only we can say that these two triangles will be similar. We do not have to prove the ratio because it is already proven that if all the corresponding angles are equal, the corresponding sides will definitely be in ratio, okay, or will be in proportion. So that's why by triple A or AAA similarity criterion, if we can prove that the angles, corresponding angles are equal, then we can say those two triangles are similar to each other. We have the AA similarity criterion as well. This is actually the extension of the AAA similarity criterion. It's not a separate thing, it's the same thing. What does it say? If two corresponding angles in two triangles are congruent, then the triangles are similar. Now, how can we say that? In the previous theorem, we said that we have to prove all the three angles are equal, and now we are saying we have to prove only two. See, by Euclid's geometry, we have seen that if we have two angles, the third angle is automatically calculatable, right? So if two angles of a figure are equal, obviously the third one will be equal. If, say, for one triangle, one angle is 90, another angle is 45. Definitely the third angle will be 45. So if we have two different triangles where two angles are 90 and 45, and in the other also we have 90 and 45, obviously the third angle for both the triangles will be 45, right? So we do not have to calculate, it's quite obvious by angle property theorem. So that's why if we can prove that only two angles of the two triangles are equal, then only we can say by AA similarity criterion that those two triangles will be similar. So we do not have to prove all three angles are equal. AA similarity criterion is just an extension of AAA similarity criterion. So we just have to consider it as one theorem. Next is SAS similarity rule. The theorem says that if the two pair of corresponding sides are proportional, may I repeat, if we take any two sides, okay, any two corresponding sides of the triangle of two triangles are in ratio or equal ratio or in proportion, and the included angle are congruent, that is the angle between them are equal, then the triangles are similar. We have actually gone through the same rule in case of congruency, so it will be quite clear to us. So what is the SAS criterion? It says that, say, AB by DE, okay, is equal to AC by DF, okay. If we have this ratio, and we can also see that the angle between them, this is the angle between these two sides, right? Not this one, this is not the angle, right? Again, for triangle DEF, this is the angle between these two sides, not any other angle E or F, right? So we have to keep it in mind for SAS similarity rule. We have to prove that first two sides are in ratio, okay, two sides, corresponding sides are in ratio, and we also have to prove that the angle between them are equal, okay. We have to prove that the angle between them are equal. In that case only we can say that they are congruent, similar to each other by SAS congruence rule. Next will be SSS similarity, SSS similar rule. So by this theorem what we can say, if the corresponding sides are proportional, not equal but proportional or equal ratio, then the triangles are similar, okay. This is quite easy to understand. So what does it say? Say if we take these sides AB by DE, okay, if we take out the ratio of AB by DE, okay, if that ratio is equal to AC by DF, okay, and that is also equal to BC by EF, okay. If we get all the ratios equal, in that case we can say that by SSS similarity, these two triangles are similar to each other, okay. So this will be just enough to prove that the two triangles are similar. We do not have to prove that all the angles are now equal. Now you will get different type of triangles. For that, somewhere the angles are not given, somewhere the length of the sides are not given, okay. So depending upon the conditions provided, according to that we have to go for the rules, okay. So now what did we learn today? First we have learned about similar polygons. What are similar polygons? then we learned about the basic proportionality theorem or Thales theorem. Okay, in question they may ask what is Thales theorem, so you will have to just state the basic proportionality theorem. It is very important to by heart all the theorems. Next, we have learnt about the converse of basic proportionality theorem. That means just the opposite of basic proportionality theorem. Okay, basic proportionality theorem said that if we draw a line which is parallel to the base of the triangle, then it will divide the other two sides in equal ratio. And the converse says that if we draw a line where it is dividing the sides of a triangle in equal ratio, then that line which is dividing will be parallel to the base of the triangle. Next, we have learnt about the AAA or AAA similarity criterion, and it has a corollary which is the AA similarity criterion. Okay, that means all the angles, if we can prove that all the angles of a triangle, of two triangles, corresponding triangles are equal, then we can say those triangles are similar. Next, we have learned about SSS similarity criterion. It says that if all the sides, corresponding sides of two triangles are in equal ratio, then those two triangles are similar to each other. Lastly, we have learned about SAS similarity, which says that if any two sides are in proportion to each other of the two triangles, then we have to check the angle between them. Okay, no other angle, but if the angle between them are also equal or congruent or same, then we can say that by SAS similarity criterion, they are also similar. But even we have the similarity rules, we have to keep in mind that when we talk about similar polygons or similar triangles, all the angles should be equal and all the sides should be in proportion. Corresponding sides should be in proportion. So if we ask what is the criteria of similarity, then we have to state both the points. If we ask for the rules, then we can talk about these different similarity criterions. Okay, it's better to write all the theorems in your copy and by heart them. That's all for the day. Thank you, everyone.